So what we're discussing last time?
Linear regression, polynomial regression.
Polynomial regression we did, right?
See, one question I have, maybe you can answer it. What is the actual purpose of machine learning and deep learning? You mentioned especially for supervised learning, I mean, it seems like more predictive analysis. I feel machine learning is much more than that.
Of course,
in terms
of course.
It's just not predictive analytics. So, are we saying that the supervised machine learning
is a part of machine learning?
No, that is fine. I'm talking about the application. Other than predictive analytics, is there any other field where it can be used? I'm trying to think of use cases, business use cases. Let's say if I have to talk to any business, any company, and that company can do anything, So how do I sell the case of machine learning other than predictive analytics? Because analytics has been there for quite some time in terms of data analytics, and it has evolved also over a period of time, from Hadoop and to Spark and R, So what is the actual? How can you sell a business case in terms of other than predictive analytics?
Okay, so one thing, the another purpose of machine learning is identifying relationship between the data. Okay.
So that is not supervised.
That is not supervised. That is unsupervised. That is unsupervised actually.
What about this cognitive skills? Like in terms of, I was part of one of the Azure presentations, which is from Microsoft. Now they talk about their cognitive, I think, services which are already like speech recognition, text recognition. So is that part of unsupervised?
No, that is
not, right?
That is not. That is supervised only. Okay, and what it is trying to do, no. It is trying to identify whether you are smiling or not. Okay, based on your photo, actually there are equipments that based on your voice and your face, it will identify how sad or happy you are at a point of time. Okay, so based on
facial recognition. Okay, I'm not getting into features. Let's not get into features. I'm just trying to understand a business use case. So let's say if I have to sell to a company, what machine learning can do. Okay, so then what should be our approach other than predictive analytics?
So see, if you okay, I'll answer it in a way that So what you want to do? You want to. I mean, it might be related to how you want to present yourself in a company, right? Or how you are basically solving their problem. So essentially, understand it this way. This definitely can solve a lot of problems which a lot of companies can face directly or indirectly.
Yeah.
If you are proposing something that is minimizing their cost, improving their performance, anybody will buy it. Anything. Okay, so of course, when you measure if a product or if an idea makes sense to a company, you have to check on these two parameters, and for that you might have to know the domain on which the company works. For example,
which is fine. I'm totally in agreement in terms of the cost benefits and the value proposition which machine learning can get into, and we need to know the domain of the company. But for that, I think my understanding on what machine learning can deliver should also be pretty good, right? Other than predictive analytics. You get the point. So, if we are saying cognitive skills or cognitive services, these services, other than facial recognition, are self-learning, right? To a certain extent, that is a value add which is being brought. I was seeing a video which came to me in China. They have implemented 1 million cameras, AI cameras, and those cameras do facial recognition, and it is being utilized by Chinese police. So, let's say, they give an alert within 7 minutes that person was tracked down based on the facial recognition. So that's a use case in terms of what AI or machine learning can do in terms of facial recognition that police is able to use. Same way, definitely there's a level of prediction over there, but the idea is, I think, from that face, you also get the history, the data associated with that person, and then do an analysis in terms of does he have a criminal background or not, and is he or she being wanted or not. So that is a kind of analysis which is being done in the back end, and then it is being presented in the form of this person is needed, yes or no, by the police. So you get my point. You're trying to get my point. Like,
So,
other than predictive analytics, is
what all can you
else,
do?
Yeah, what machine learning can do? In everything, I understand. You can sell that I'm willing to do any number of predictions for a company. Let's say any company, and you can have the value proposition and the cost benefits associated with any kind of prediction, right? If you're able to predict what is the future, company will be, director will be jumping off the chair and say that, okay, give me that product. But other than that, what are benefits machine learning can derive?
See, I mean, you took a case of like if you are able to predict faces, you are taking that example to catch thieves or maybe automate classroom attendance, right? School classroom attendance. There are a lot of such cases when you talk about facial recognition. Then suppose you, I'll give some more examples. Suppose you are a company. This is one case. Picasso is dead, right? I think everybody knows that, right? So suppose you want new paintings of Picasso. Of course, Picasso is dead. You cannot make him paint, but you can train a machine learning model, basically that is called GAN, with Picasso's previous painting. It will learn, and next time onwards, it will do the painting the Picasso style. Understood, right? Okay, so this is one case. This is one case. I mean, what does it mean that if you teach, suppose I am here today. Going forward, I definitely bang for a technology where I don't have to come here and teach. What would I want is that and of course we want to expand as a company, like 10 places, 20 places, and we still want to maintain some sort of quality, right? What do we want is we want to really add replicas. So won't I want my replica to be over there? So there is a machine learning model where it hears me talking, discussing, and it learns how to replicate this model.
So then I think what you are giving as an example is machine learning coupled with some other technology, let's say augmented reality.
Yeah.
You need to have the coupling done, or robotics. It cannot be just machine learning in single active.
It can be software which will just learn how do I talk, and it will try to replicate it, and it's not very difficult.
Can you get like specific example, say for example retail industry, like where we can utilize?
Say for example, you have a okay. So 12:30 we'll do this discussion. After that we'll get back to the work. We have 6 minutes. So one retail question, one question.
The algorithm which you will discuss with us in this machine learning program, those are only those which are listed in this curriculum?
No, there are few more than that. Actually, there are at least 20-25%.
Just name of those after that.
I can do that. Okay, coming to retail industry. Suppose I think I was giving this beer and diaper example. Try to remember, right? That is one case. Second is if you can predict, that tomorrow I don't expect a lot of people to turn to my store. You can. Which one?
Beer and.
That was unsupervised. Right. So secondly, if you can predict, tomorrow my footprints will be lesser, right? Based on the previous knowledge, footprints will be lesser. You can, give off to some of your people. That may be good time to give people off, right? Okay, if you want, they are talking about not 1 to millions of sales product, right? And sometime, during Holi, sales of some product will go high. If you know every day that, what will be my sales for this whole week, you can pre-stock yourself so that you don't have to do last minute stock filling and all that, right? So this sort of things. And a lot of them are there that, if somebody is buying one product, okay, what sort of message you can send him so that he is see in shopping malls. What do you see? The necessary items are kept in the end, right? I think when I noticed, if you go to Hypercity here across the road, I wanted to buy milk. Okay, just because I happen to go there, I have to go through the entire Hypercity mall. I'll end up buying 10 more products. Generally, if you see the stats, people go in a mall to buy 10% of the product that they end up buying. So it is around 90% plus products that he ends up buying. That is the level of analysis that happens in, say, retail market. Yeah. Any more question? I still have 4 minutes.
Yeah. Okay. So one question on the IoT. The other day you mentioned that possibly you will start another course on IoT. Now, is there a different software that is used for IoT, or is it network
Yes,
is used for
IoT is
the ways I understand it's IoTs are sensors which are reading the machine behavior over a period of time and capturing the information secondary on the network, right? And then you have some machine learning software trying to understand or decode that information.
So IoT is right from getting the data in a sensor, which can be anything. Like for example, this thing, this police patrolling stuff, right? Automated police patrolling. So something which is getting the information of the area. It can take photographs also, as simple as that. It can identify moisture level also. It is sending some information. But IoT is not only getting the data. There are a lot of protocols there in IoT. It's quite evolved now. It is not the same it was before. It is not really only Raspberry Pi. Okay, there are various IoT protocols. Okay, where the data is received, processed, taken forward, and so on at various levels. And finally, the convergence happen when it ends in a cloud where the data is processed, compared with other data. Then there is some dashboard which shows you some information. Then there is some predictive analysis that happens on top of that. Based on that, there can be some action.
Is there specific software used in this?
IoT, like for cloud also, there are things like Splunk, there are things like AWS IoT, but there are a lot of services. Yeah, IoT is quite mature now. I mean, it is ready for.
So what they have, basically they have the connectors to fetch the information.
So there are a lot of components. One is getting the information. Information is received. Information needs to be converted into some format which can be processed and understood by cloud applications and all that. So those things are there. Then there can be a lot of information. So you're talking about IoT is explosion actually. Okay, because number of end devices increases multifolds now. Okay, you are talking about getting information from all those devices, converging that, concluding that, and then taking it forward. Right, I mean,
it also means like, let's say if I have a refrigerator at home, if I want to extract information on how that refrigerator is performing, that refrigerator should be connected to nature.
Of course, everything. That's smart. So the number explosion is huge. I mean, the number of devices that gets into the market because of IoT is huge. Like now we have per person around 2 to 3 devices which is connected to internet. That time, right from your watch, right, smartwatch to your Fitbits to, I think more or less every person will have some 10 devices connected to the network. So we are talking about network explosion. Okay, so a lot of things are there in that ecosystem. Like if your Fitbit will send to different infrastructure, your phone will send to different infrastructure. So you're talking about a lot of data. Your self-driven cars. If you think that is one case of IoT to a certain extent. They are generating some 40 GBs data every hour.
Okay, so what I was trying to say was, even if you have smart devices, you need to have the infrastructure,
right,
to support that.
Infrastructure is.
If you have, I mean, I'm not talking about India, but in other countries, maybe you have that bandwidth 40 GB per hour. What you will do with the fridge? You generate 40 GB per hour of data. When that does not get synced up back into some device.
I mean, infrastructure is getting ready in some of the major cities. As you have the infrastructure, Hyderabad has. I mean, of course, this needs some government backing.
Is it government initiative or is it a private company initiative?
It cannot alone be a private company initiative. It needs government backing on various aspects.
Some time to go there.
I have another.
Okay.
So now this last class when we learned about this linear regression. So actually, firstly plotted different curves and finding out the cost function, then with the minimum coefficient, like we found out the ideal. So when we are doing that matchworking plot, how it is doing that plotting? Like, is it doing the similar way calculating and?
No, it is plotting the data. This particular x, this particular y, this is the point. This particular.
But how it's normally randomly?
I mean continuous.
Yeah.
Like everything. I mean, if you say 2 points are there, you'll try to connect with a straight line. Just that if 2 points are very close to each other, you'll see continuous.
Exactly.
Yes, I think we have 5 people joined online, and here we have 4, 5, 6, 6. Okay, cool. Let's get started. Okay, so we have seen some pre-processing in our previous session. Okay, we primarily used polynomial features, right? And the purpose was it converting from your one-dimensional data into multiple degrees, and we found coefficients for that, isn't it? Okay, like you have the data, it will generate x square, x cube, and all that. We found coefficients Okay, so that is where polynomial regressor came into picture. Now that was something known as pre-processing. Okay, we'll now see today the entire list of pre-processing libraries. This is all there in GitHub. Okay, so what is pre-processing? The purpose of pre-processing is changing the data to some format based on which machine learning algorithms can work better. Okay. Okay, so this is there are two things. Okay, one is transformers. Note it down. I mean, the terminology is very important here. Changes data from one format to another format. Okay, what does it mean? Suppose some machine learning algorithms works well on data which has central tendency of 0. That means which has mean of data towards 0. The data is between 0 and 1. Some data format is there. Okay, so so you whatever data you have, you need to convert that into that particular format, right? This process of converting data from one format to another format is known as transformation, and it is done by transformers. There are a lot of transformer APIs. Fine. Okay, then the other thing is estimators. Like for example, algorithm which you do the prediction, like your linear regression algorithm last time. From text to number, image to number, from number to another format of number. All these are known as transformation.
Final conversion will be in numbers.
Numbers, right? Machine learning algorithm, as you have seen last time, it is all numbers that we need to convert the data into.
So there are some inbuilt transformers.
Yes, inbuilt many transformers. We can write our own transformers as well.
So for this image, text, voice, everything.
Voice is also nothing but numbers, right? So once you have something in numbers, you can do machine learning on top of it.
There is uniqueness also, right?
Of course, there is.
Once you're transferring voice, every voice is unique. Image also.
Right. So there are this. I mean, what is this? Your audio file. This audio file is nothing but data, numbers. Okay. So let's see the second thing. This is the link which contains all the pre-processing APIs. Of course, I have spoken a little bit about it. Okay. So a scikit-learn pre-processing consists of common utility function and transformer classes for converting data from one format to another. The target format of data is very much suited for doing machine learning. Clear? What is transformers? I'll use this term very often throughout the course. What is transformers?
And when do we do this pre-processing? What stage?
Yeah, you will do this pre-processing after you have got the data, cleaned up the data a bit. That means you have removed unnecessary information.
If we have data set, then the cleaning is also that needs to be done by us.
Right.
Cleaning means like what basically?
Some data, some information which is not relevant, some empty information, right? Some incomplete information. You want to get rid of those.
Some outliers also.
Yes, that can be also one thing. Okay, so this is pre-processing. Okay, pre-processing means text to numbers, numbers to numbers, image to numbers. All these are pre-processing libraries. Okay, so and the last thing is the algorithms work well when the data set is standardized. What does it mean when it's standardized? Some algorithms tell that if the data is of this format, I will perform better. Right? That is known as standardization of data sets. Okay, so what you need to do with pre-processing APIs, it is to use those transformation APIs to standardize the data set so that machine learning algorithms can behave well.
Standardized data set?
It pretty much is in line of how the algorithm expects it to be.
So when you say transforming, transformation is different from standardization, right?
Right.
So we are asking two steps to be performed there.
Right.
One is transformation and then standardization. What if can't we perform processing on a transformed data without standardization? Can you do that?
Processing on a transformed data
without standardization.
Of course, you can do that.
What is the impact of performance?
The impact of performance can be less to more. Okay, we'll see that a couple of percentages depending on algorithm, and there are a lot more parameters here which can
I think it has to be a more representative analysis of the computational resources that you're asking to add more. And the similar way, like in terms of, let's say, if you are not doing this standardization, the less competition that you're supposed to do.
Of course, if you do no computation, you'll get nothing. Of course, standardized mean you are adding some computation requirement to that, definitely. But the benefit you get is better accuracy.
better
accuracy. The algorithm will be predicting better how many number of sales will happen. It will be identifying your emotions better, right?
These sessions are not being recorded.
Yeah, it is getting recorded.
The past all the sessions.
Sessions are it is recorded. We need to do some processing before you upload it.
I want that.
You want the recording? Okay. Whatever you speak is getting recorded.
Yeah, that's it.
So in between, you said estimate or something.
Huh? Estimator. Everybody understood transformers, right? We'll see some examples. Okay. Estimators are the algorithms like predictors. Okay. Like linear regression, logistic regression. These algorithms are known as estimators. Okay. Let's keep the term open. We'll see pipeline and all those concepts. I'll use it in infinite times. Okay. Let's see some very simple pre-processing libraries. Okay, from sklearn import preprocessing. This is the preprocessing library. This library has a lot of things, and we'll be using this submodule a lot. Okay, import numpy as np. Okay, then what we see here, we have a numpy array, randomly initialized numpy array. And what you're doing next to this is we are doing a scale operation. What is the purpose of this scale? It is a mean removal. Okay, across the column. When you do this, you'll see the mean of the column is 0.
What is the intent of doing it?
Why do we do it? Okay, so this is some algorithms work well when the data has a central tendency of 0. Central tendency of the 0 means if I plot the data, you'll see a lot of data the entire data is getting plotted towards 0. You have a x-axis, y-axis, right? 0 information. If you plot this data, you'll realize a lot of data is plotted centrally towards 0. That is information.
So by using this, what you do?
By using this, your algorithm might actually work better. Understood, right? So if you see, these are tricks. There is no hard and fast rule. You do this, you'll get this. You'll not do this, you get this. But it is recommended that this algorithm works better with data with 0 central tendency. So so that is a topic I'll be discussing in a while. But the thing is, there are a lot of such pre-processing technique, and that is where you really don't have a magic formula to identify. Some ways are based on intuitions, some ways are based on your knowledge. But when you are starting now, what you have to do is you have to try almost a lot of things. So remember, that is why I used to mention earlier, machine learning applications writing are very much iterative in nature. You write your code once, finish the code, see the accuracy, then you realize that let me change these things as well. The way we used to do experiments in our chemistry lab, right? We maintain a logbook, right? This data, this was the result. This data, this was the result. So you can very easily write a very reusable code, as we saw last time. That means one code which will test for all different type of polynomial degree, and it was giving the results. Here also we'll see that we can write such code very easily. Code writing is becoming very easy, so you don't have to have a lot of depth in why? Because the reason is it is too much. You cannot wait to learn, wait before you start working all those details, isn't it? You don't have that much of time. So that's why the idea to unblock is try out all the stuff.
So this scale, what is it? 2D. The scale function, what it does?
Scale, yeah, the central tendency of the column data will be 0. See here, the data is 1, 2, and 0, right? It won't like from the 0, the farthest data is 2. Right, distance is pretty much. So if you see from this 0, the farthest data is 1.2 in this case. So data is moving towards 0.
The mean will be 0 only in the data set when they are positive and negative numbers. If they will all be positive.
No, see here, it was positive. All the numbers are positive, right? It converted into negative.
So 1, 2, 0. What the mean will be nearby to 1.5, right?
This is 0, right? Mean sum of all the numbers is 0 here.
Initially, we are having that data which is in 4th root, and after scaling, we have in 7th.
See, sum of all this data is 0. Sum of all this data is 0. 1.3 minus 1.23.
Has converted.
Right. So this data it has converted to this format.
Why? What is scale to? Why you are trying to do something?
So as I was mentioning earlier, scaling. The idea of scaling is to convert data to a format that machine learning algorithms works well. First point. Okay, so machine learning algorithm works well when the data have central tendency of 0. So that's the second point. Okay, so what will you do? You'll do first point because you need second point to be done.
So every time you have to do scaling?
Not always. And that is why here question came into how do you realize when do you have to do scaling? I said that there is no magic formula to know that.
No, so I think your statement is the data works well when you have the data around 0, the central tendency is around 0. So you are basing your statement on some assumption that the standardization of if we do standardization of data using scaling, the output will be much faster or much accurate. That's what you said, right? Accuracy is more if you are doing standardization. This is standardization of it. Scaling.
Accuracy is more, right?
So why would we do?
Not because I said no, because I said not always. This is the case.
Let me give an example. Like you are contradicting your statement. You
No.
that you are actually making data into a format where the algorithms are much more computational friendly, or how should I say, accurate, predictive friendly, as compared to non-scale data or non-standardized data where the accuracy is less. Why would I go there?
No. What I said is not always. That's what. There is no rule. That's the first rule of machine learning. There is no rule. Okay, because there is no way that you can conclude. Actually, I'd like to give an example over here. Suppose you have image data. Okay, in image data, what is the information? Each pixel value is that is what it is. Right? Each pixel value is RGB. If anybody has image understanding, each pixel is represented RGB. What is the value of this RGB? 0 to 255. Machine learning algorithm do not work. The image processing algorithm do not work well with such type of data. What you do there is you divide each data by 255 so that the value of each pixel is between 0 and 1. Then the algorithms work well. Got it, right? So you have.
So then it depends on the type of data which is there in the raw format.
It depends.
We need to understand what.
No. At this point of time, I'm just talking about the pre-processing stuff. Okay, this is the utility. This is the utility. This is the utility. Okay, we'll use it in our near future when you're doing the algorithms. We'll use many of them. Okay, then you will make more sense that okay, this is how we are using. I won't be discussing here a lot when to use it. Understood, right? Here we are just you know overall that okay, these are the algorithms. Okay, this is what we can use. But at this point of time, it is not possible to understand when you really use it and what are the, because without understanding the algorithm, you really cannot understand what is the benefit of this. Okay, so first you have to understand. Okay, these is as of now. Okay, as of now, we'll go through this library, and what will you do is you'll see, acha, this is one API. This will convert your data to this format. Just understand that part. Later on, when we learn algorithm, we'll connect these two. Okay, now that this algorithm works this way, okay, we can connect this particular transformer to this algorithm.
Are these calculations being only related to linear regression models?
No, all of them. Okay, so don't get confused here. The first point you understand is you are basically converting your data to some format which is suitable for machine learning algorithm. Some of the machine learning algorithm, not all, and not always it will work. Okay, but many times it is good. Rule number one. Okay, so without really understanding the algorithm, you cannot appreciate why this is happening. So as of now, what we have to see is we have to see, okay, this is the algorithm. This is what it does. We'll use it later. These are like tools. We're getting it ready for because we saw right earlier we use this polynomial features as a transformer which converted your data into that format, and the algorithm worked well for that, right? Similarly, we have a lot of such things coming up, so we have to understand these things so that we can apply these things later on and then understand it complete. Okay, let's proceed further.
The feature selection, those will come later.
Those will come later. Okay, as of now, what you are doing is you're basically converting your data from one format to another format. Full stop. Okay, and why you are doing it? Because in some cases the performance is better. Next point. Just take this as an understanding and proceed further. Okay, so
transformation and scaling are same.
Scaling is a type of transformation. Transform is a big bucket where it deals with conversion of data from any format to any format. Okay. Now, okay.
Axis 0 means column wise.
Axis 0 means columns. So what are you doing here? You are creating here a standard scalar object, right? And see what you're doing here. You are creating an empty transformer. What is the purpose of transformer? Conversion, data conversion. Huh? Okay, so when you do fit to that, it will actually when you do fit to that, what will do? It will actually create a mapping. Okay, create a logic for transformation. Like in the previous data, it created a formula which will be applied to each data, and it will create a new formula for that, isn't it? So that is your formula that was generated. Okay. Similarly, when you do fit here, what is it doing? It is creating a logic of transformation here. And then when you do transform, the actually data is getting transformed. So if you want to do creating the logic and transformation in one shot, you do fit transform. Okay, so there are two APIs. Okay, three APIs here. One is fit. Fit is to create the mapping. Okay, that means when you do a standard scalar transformer.
Just for the sake of attendance, just write it even though my class. So once this is done, just
Okay.
write.
You can write your phone numbers also next to that. I think this will help creating the WhatsApp group. I think that was the purpose. Just write phone number next to that.
So it will create mapping, and transform will do what? It will do the transformation.
Right. Then it will do the See, first it will create the mapping.
What type of
mapping means what is standard scalar? It is some function which will create the logic. When you give this data, it actually creates the logic using it.
What do you mean by logic?
For example, if you, we'll see this fit transform and fit transform APIs later on as well. So what we'll see, suppose you have some text. I'll give you a very simple example. You have some text and you have to convert text into numbers. When you call fit function, you'll be creating a mapping table where each word and corresponding numbers are created. Understood?
Every time you call?
When you
using the standard
standard scalar,
scalar?
or in later on TF-IDF scale, TF-IDF, all those things you have to call them.
Fit function has to be
Yeah. Okay, fit function is to create the mapping. Okay, remember fit function we used in our linear regression to train the model. So here also you are doing a training part only, creating the mapping.
Standard scalar, but
same thing as before. Just the representation is different. We saw the pre-processing scalar, right?
But here it says it's an object, right?
Yeah.
So
pre-processing scale, this was an older API, but this is how you write new. What is that? Converts the data with column of mean 0 and column standard deviation is equal to 1. Right? This is the purpose of.
Then means mean of the column will be 0 and standard deviation will be also
1. Right.
So that normal scalar also does the same thing, right?
Do the same thing, and that's what I'm saying here. So pre-processing, see this is the API that you will be seeing more. Okay, so you will see this transformer dot fit function. Okay, so this is the standard way of doing it. So how you will be creating a transformer? We'll call a function with fit. We'll call that after the training is done, you will call the function with transform, and the data is transformed. Or if you want to do training and transformation in one shot, you can call this function fit transform. Is it clear? You will get it. So this process is this is the you create these steps are you create a transformer object, you fit it, you transform the data, or you do fit transform.
So transforming the data has to be done.
Transforming will actually give you the return the data on the transformation, right? So that you can use it later on. Let's see further, and when you do applications, you'll get it.
So instead of standard scalar, if I do any other transformation, so it will transform accordingly.
Right. Let's see here. For example, you have this guy min max scalar. Okay, min max scalar means whatever data you have, right, you will convert it in the range of 0 and 1. Okay.
Randomly.
Not randomly. Of course, nothing is random. This data is relevant to the actual original data. How does it do that? It divides the data between, suppose you have the extrain, right? Your extrain data is ranging from 2 to 7. You have to convert this data between 0 and 1. What does it do? You will divide each data by 5. The difference between the max data and min data. It will convert all the data between 0 and 1. Clear?
How can you repeat how it converts?
Yeah. So let's see the case. Extrain is here, right? Let's see the data. You have this data say extrain. Okay. So what I just mentioned here is
Convert data 0 to 1.
So across the column. So what is the min data 1? What is the max data 2? Okay. So this is min. Min data is 0, max data is 2. Okay, so what is the difference between the data 2? So what will you do? You will divide each of these data by 2. So 1 by 2 is 0.5, 2 by 2 is 1, 0 by 2 is 0, right? So that is what you see the data.
This is feature scale.
See, 0.510.
So this mean max scalar, like the variable also is a transformer object.
Which one? Min max.
An object which gets
this is a transformer object, and you are calling this function fit transform, so that you can do the fit training part and the transformation part in one shot. Then you have mean absolute scalar. What will it do? It will do convert data into. So you have such utilities. Now, of course, the question is which one to use. That is what you will learn eventually over a period of time. But these are tools. We'll use them. Okay, so few of them are mentioned here. Your mean absolute scalar. Okay, but so what you're doing, you're not changing. You're changing the data, of course, but you're not changing the relationship between the data.
So another second will be another level.
Right.
So this transform data is specific to the source, like that is like relationship is maintained.
Right. So that is what is important here. So remember, you are transforming the data. That means the data contents are going to change, but you are not doing any changes in the relationship between the data. Right. Okay. So later on we'll see if you do too much of scaling, that might not be good also, because you would have changed the data a lot.
This divides the minimum maximum by 2.
Min max scalar, what it does, it divides each value by the difference between the max value and the min value.
Can you come again?
Min max scalar. Yeah. Min max scalar actually divides each data by the difference between max and min. That is your min max scalar.
So is the accuracy improved? I'm just trying to understand why are we using standard scalar and min max scalar? That we use just one.
Because range is very large.
See, that typically the behavior is different. Right, one guy is dividing from the maximum value, other guy is dividing from the difference between the min and maximum value. So min max scalar is more evenly distributed data. Right. So a different algorithm has different benefits. Okay, different algorithm has different benefits.
So this is going to depend on the data set that we have or the
algorithm data set both. Right. So this is
somewhere it should be called out, right? So this needs to be used on this particular data set, then it will be much more easy to correlate. Otherwise,
I gave one example of image. Okay, but as we proceed further, we'll see that we'll come across a lot of cases where we are using few of these techniques, right? Because these things are difficult to understand when you don't know the algorithm. When you know the algorithm, like for example, I gave a case of image processing, right? And it is for image processing, it is always the case that you will divide with min-max scalar. Right? The lowest value is 0, highest value is 255. We'll do with that, and you will get a number between 0 and 1, which will be acting as machine learning.
So that is why you see, my question is not on that, not exactly on the examples. My question is, let's say, standard scalar. I should understand what is the basic concept behind it. You can explain that with examples. So that is the one way of explaining that. Okay, you can give me examples and explain, okay, this is the standard scalar. We are converting data. It's now some kind of transformation from in this way. I think there is some. My thinking is there is some statistics or mathematics involved.
Of course.
Over here, like in terms of that, why standard scalar we are converting data this way. There has to be some mathematical reasoning in terms of let's say the difference between min-max and the standard scalar. There is some.
So that's what I'm saying. The mathematical
is involved. For me to understand the basic concepts, because otherwise, see, examples can definitely ring a bell. to correlate. But the basic concept should be understood, right? So I'm not able to understand what is standard scalar, like in terms of you're just telling me an answer, a definition, right? It is just like this. But what is the basic concept of standard scalar? Where it is used? I mean, forget where it is used, but for the conversion of data, why are we doing this conversion of data this way? Is there a mathematics formula that is telling us, okay, do the conversion of data this way? Same way for mixed min-max scalar. I mean, min-max scalar is slightly more easier in terms of because it's kind of dividing the data, between min and max value. So you get my point. You can give examples and we can talk about it like in terms of, yes, this is one example of standard scalar, one min-max scalar. This is some kind of transformation that we're doing.
So you have. So that is what I was talking in the beginning. That if you have, we know what it is doing now. How it is doing, why it is doing, we'll be able to understand only when we see the algorithm.
But shouldn't that concept be clear now?
It cannot be.
I'm not talking about the algorithm. Let's not do the algorithm. Okay? I'm talking about the logic behind standard scalar. Somebody has put some logic behind standard scalar. It is not related to algorithm. You're trying to transform the data or standardize the data in some format, and for that you're using standard scalar. I'm just speaking about standard scalar. What is the logic behind that?
As I mentioned, that there is two logic. One, some algorithms work well when you do this. Why some algorithm work well? Because that is the behavior of the algorithm. When you're designing that algorithm, suppose for example you want to, you are writing a formula. You are writing an algorithm logic. When you're writing that logic, okay, there is certain assumptions that you make, right? Assuming this is my data format. Okay, that is the foundational assumptions of the usage of the data. So now, when you want to apply, when your data set particularly meets the condition and you want to apply that algorithm, acha, this algorithm works well if the data is standard scalar. Then you apply standard scalar. See, because there are a lot of these mathematical things. For everything, for example, picking the standard scalar and going back to the person how this was invented and those things.
No, I'm not talking about invention detail. What I'm talking about is I think it's something to do with the data set. Yeah, standard scalar, you are applying this definition on a particular type of data set, or you will be using on a particular, let's say,
I'll be using this
data set. Let's not go to algorithm also. You understand?
Because similar like the example what you gave this image thing, you said like we have to go with the divide by 2. So why cannot we go with standard scalar? If we go with standard scalar, what will happen? I know that accuracy will not be correct. That is one thing. But if we go like why we cannot go with standard?
So we are assuming accuracy will not be correct.
Yeah.
So that's where the basic concepts. And I'm not going to algorithm also. And neither I'm going too much detail into the history of how the mathematics is evolved. What I want to understand is standard scalar, which is converting data into some format. Is it doing it other than to improve the accuracy algorithm, as what you're saying? Is there a correlation between the data set or the kind of data that is getting presented?
So that's what I'm saying. It is less of data, it is more about the algorithm. Because when data is, if you get a data, what is the next thing that you'll realize? Okay, I want this is my purpose that I want to achieve. For example, last time we were doing some house price prediction, right? We want to predict the price of the house. For that, I need to apply some regression techniques. Okay, so I have this list of regression techniques. Okay, let me try applying this regression technique. So this is what is happening. Then I think I need to scale the data because the algorithm works well with scale data. Right, then you do some scaling. Okay, then this is the case when I'm doing standard scaling and it is giving me this. Okay, so now do you want to do min max scalar and see this what is the behavior now? Then you see, acha, this is what is happening. Now there are two things. Okay, that so one indication which type of transformations to use will be given by the estimator, because you are pretty sure. See, in the entire process, okay, as I was mentioning earlier, all these things are variable. Which transformers to use, which scaling techniques to use, which data to what type of data is suited for all these things. Like for in case of image, okay, so you divide it by 255 because the image algorithm works better with data between 0 and 1. There is no, I mean, this is how it is done. I mean, if image algorithms are there, somebody who is inventing those algorithms, they've invested time and they realize that this algorithm will work for this is the potential, this is how algorithms will work. Okay, so and he conveyed that message to us via the documentation. So when you are using images, this is what you do invariably. Okay.
Related to the algorithm, the transformation is there is no specific reason why they are dividing doing something like that.
No, that is what I'm saying. The specific reason is actually the algorithm. Yeah. The purpose is
I understand that scaling has to be done, transformation has to be done. My question is not that. My question is between standard scalar and min-max scalar or X number of scalars that we have. Why should I use min-max scalar? Why not standard scalar for everything?
This is the same question. This is the same question which got answered in the last question when you have the question, okay, degree 1 is there, degree 10 is there, degree 15 is there. Which one should I use? And how did you figure that out? We have to do it.
Accuracy test.
Yes.
We have to try different combinations.
No, I think you gave a different. I mean, you gave a bit of an answer. Like in terms, it's dependent on the estimator. It's not dependent on the data set. That's what you said. That from me to
which type of
scaling?
Which type of this is the stage where you're making the data ready for algorithms, right? So that is where these are. I mean, that's what there is. We have to understand this. It is not possible that you say, okay, I'll write this code once and it will work. Unlike the traditional software development where you have this idea before even writing the code, we have already written the code in our mind, isn't it? That is what traditional software development is. Here we cannot do so because after writing and executing this, that will, based on the results, it will give us more trigger point. Acha, maybe my scaling is not working. Maybe I have to change it. Oh, then after changing it, you can, acha, maybe the data is of this format, so this type of scaling is working better. Right.
It's like a hit and trial error.
It is a calculative. You don't say it hidden trial. It is an experimental approach.
We are basically always CSS tools in our hand. Whenever we are going to try out the different options,
right?
That's when we.
This is the foundation. See, I understand. On top of this, there are certain intuitions that will develop. Like for example, one I gave about images. There are a few things I can talk about text. But remember, thumb rule is those are not rules. The point you are hardwired that this type of situation happen, I will do this. Then you are leaving a lot of things untried. So we'll use this. So when you suppose we are doing we'll see lot of text conversion techniques also. We don't know what would work, so we'll use all of them. Okay, and based on what is working out, it will give us some more intuition. Okay, maybe we do a found meaning on this. Right. The process itself is a different step. Okay.
And here there is no transformer object created in the next scale. Do we have a transformer object?
Yeah,
it creates.
Yeah, it creates.
What is scaling outliers and?
Yeah, I'm talking about. So I was just talking about what does scaling do? It is changing the data. Okay, but changing the data can impact in the changing the relationship between the data. Okay, what I mean by that is sometimes the relationship between data is very important for doing the predictions.
Original data.
Original data. And sometimes the information can be irrelevant completely. One column can be completely irrelevant from other column, right? And if you try to do scaling, somehow there can be a fake relationship that will be built up. Is this line clear? If you change data, there can be a fake relationship which can build up, which can give us wrong indication. Okay,
so it will come up at the time of testing accuracy test.
Right, it will come up in the time of accuracy testing, and there are certain things that you do to find which are the relevant features, which are the correlated features. You will see those algorithms giving you fake information.
So, like in cases when there are in the data set, we have some columns which don't really make sense in the prediction.
And all of a sudden, after scaling, they started showing some fake relation. Right, this is a dangerous situation, and when you do scaling, let's be aware of this, that we can get into this situation.
So how fake relationship can be tested?
See, the only way to test everything out is your validation errors.
Like accuracy.
Accuracy. Okay, if you see the accuracy is not working well after scaling the data or after scaling some part of the data, you can think that your scaling is actually skewing up the relationship between the data. Right, so that's why this is not a one dimension. When you're thinking of a problem, you are not thinking from one dimension, you're thinking from multiple dimensions, right? That is where it gets involved, it gets little difficult as
Okay.
What is sparse matrix?
Sparse matrix, any idea? Anybody?
Very far.
Yeah, in a matrix where lot of zeros are there. There is a sparse matrix. Okay, so this is a situation where it might not work well. One is here, it can skew up the relationship between the data, and second thing is when the data already had a lot of zeros in it. Okay, sparse matrix.
So what should we do in sparse matrix? We should not do scaling at all.
You should not do scaling. That is not recommended. But again, when I say things like that, it's not that this is thumb rule, right? I mean, that is definitely based on a lot of experiments. Okay, few things work out, but we cannot conclude that. Okay, that's the important thing here.
Scaling out there, what is the scientific name used for finding model?
PCA. What is PCA?
We'll discuss that later. These are feature selection techniques. Just remember as of now that the relationship gets skewed up. When you discuss PCA, I will talk about scale. So okay, next thing is normalization. What is normalization?
So one last question.
Yeah.
So estimators on standard scale and mixed square scale, what are they?
They can be your linear regression, logistic regression. Estimators are predictors, algorithms. Okay, estimators are predictors or algorithms.
So are these only for supervised or more unsupervised?
All. Okay. And those are also known as estimators, right? In this case, let's say this case when you say normalization. Normalization means it is trying to cut down the peak information of the data. So that normalization you need, right? There are peaky stuff. You just tape it down.
Outliers.
You can say that. You can say that if your data has too much of outliers, you would prefer to normalize it first, then take it forward.
This the final graph should be smooth,
not spiky in nature. Absolutely. Yeah. Okay, for that you have this normalizer. So if your data had like she pointed out your data had some outliers information. Okay, you think that it will skew up your predictor, isn't it? If your data had if you're doing salary prediction, if you are getting somebody's salary in the data sheet, it will increase everybody's salary by some ratio, right? So that is an outlier information. So what would you do in that case is basically, okay, so what you do in that case is you'll normalize the data. Okay, normalize the data means reducing the peaks of the data, and that is what you have done there, and this is the result that you get. But the important thing is fit and fit transform. So if you don't want to do fit and transform separately, you can do fit transform. It will do both of them in one shot.
Such type of means outliers kind of thing is removed during the data dynamic also. Your data.
Yes, you can do that, and that is why this is part of data.
We have not done at that time.
You can do it here.
I can do it.
Yes. Got it, right? I mean, it will start making sense. I mean, once you know the tools, you get the data, you'll start connecting. Like there is one algorithm that is known as binomial name base. I'll discuss that later. What is the algorithm that works? Real algorithm worked in binary data, 0 and 1 data. So what do you do for that algorithm? Given the data, we'll try to convert into 0 and 1s. Understood, right?
Won't normalization also can possibly disturb the relationship between the data?
Of course, anything which you are changing the data, right, it can disturb the relationship between the data, indeed. Okay, and binarization, it will convert your data into 0s and 1s, and there are some algorithms like they say binomial name base that requires binary data. So you'll do this transformer before you subject the data to binomial name base, right? Now, important point: categorical data. What is categorical data?
Non-binary data.
Yeah, categorical data means like, for example, there are two types of data: categorical and numerical. Categorical data needs to be converted into numerical data. Say, for example, many algorithms works well when the data is in form of a vector. You don't one hot vector. What is one hot vector?
What?
Hot vector.
We don't know what it is. I don't know what it is.
Vector is what do you say? Matrix. Matrix is clear, right? Matrix M cross N. Vector is one-dimensional matrix.
Only one column.
In only one column or one row? Absolutely. right? So any data, like just remember this thing in machine learning, whatever data you have, right, the data is internally represented in form of a vector. Okay, like for example, you have a person's detail, you have to find
target data.
No, your input data also
Feature. Matrix form, right?
That is matrix form, because you have lot of rows.
Correct.
Each row is one vector, isn't it?
Yeah.
Okay, so that is what I'm trying to say. If you have a lot of people and you have people's information, each person is one data. Okay, then each person will be represented in form of a vector, and in number of entries in the vector will be number of features. Understood, right? So I'll use this term very often, and you'll hear this term also very often. That's why the vector compute the distance between vectors. That means you're trying to find how much far one data is from another data. Okay, when you have to connect this logical world into mathematical world. So that is where vector is doing. Vector is representation of some logical data. Clear?
So that comes in picture for unsupervised.
All the cases. Okay, because everything is a vector eventually at the end of the day. If you write some text, you write some numbers, you have some image, everything is a vector at the end of the day. So that computation can happen on top of it. Let's see the next guy. It is one-hot vector. Was one-hot vector? Let's understand. One-hot vector is like, first you see these three guys there, right? If you represent in vector format, you will see 0, 0, 1. Okay, then you see, that means the first column represents 0, second column represent 1, third column represent 3. So whichever is value is assigned corresponding to that particular column, the value will be 1, others will be 0.
No, I also didn't get how the output is coming like this.
Huh?
How the output is coming like this. One hot encoder.
Now
2 array after 2 array.
Okay, so now I remember in school colleges we have to have this what do you call the aptitude test sort of a thing. Okay, keep that bit on. Okay, wherever you think these things are happening, keep that aptitude bit on. It will help. See this. You have this. If I ask you to find the relationship between this data 3001 and this data 001, right? 3 and this data, what will it be? First, here it means first column will represent 0, second column will represent 1, and third column will represent 3. So if you have to represent 3, you have to mark the third column as 1. If you represent 0, mark the first column as 1.
Whatever.
So you have this data. These are your 4 data.
Like so,
Four data. One column feature data, and you have 4 data. 3, 0, 0, 1. Okay. We have to now create a vector format of it. That means from 3001 vector format, vector also one-hot vector. One-hot vector means all the data will be 0 except for that particular data which it has to represent. What I mean by that is, for example, in this case, you have this 3. You have to represent 3 in 0, 0, 0 and 1 vector format, right? One-hot vector. So what it is doing, this third column you are saying 3. So you are marking this one. First column you are saying 0. So you are marking this one. Second column you are saying 1. So you are marking this one.
So first that data already is a vector only, right?
No. That is the data. 3 is one data.
Okay.
0 is one data. 0 is another data. 1 is another data.
That altogether is not a vector.
That altogether is not a vector. These are different data.
But if there is the permanent answer.
You can see bracket inside bracket. So different data. Or what you can do is,
first we represented 3, then 0, then 0, and then 1.
Yes, maybe if I draw it like this, it will create a lot of confusion.
Vector representation of each.
So this 3 is represented like this, 0, 0, 1. 0 is represented by 0, 1. This is because here each column means something.
If instead of 0 in the 27 we have 2, we have 5, then also it will be 1.
No, yeah, then you'll need more columns to represent this data, right?
No, for example, instead of 0 you write 4.
Nobody's getting it. I thought it will be clear from the diagram itself.
Here 2 is missing, no?
No, not required, right?
Okay, here we have 2, that's why we are using the third column.
Actually, for 0, if you are putting 1 in first column, then for 3, why like in third column, it will be fourth column, right?
Wait. See, now you have how many? You have what is the possible values? 4 possible values, right? So you have 4 columns. First column represents, I can do this. First column represents 0, second column represents 1, third column represents 2, fourth column represents.
Second is something active features.
No, I'm just, this is showing the column number mapping. Okay, the first column means 0. So wherever it is 0, the corresponding value will be 1. Wherever there is 1, this is the column which represents 1. So wherever, see now earlier it is 0, right? So first column is, if I change it to 1, what will it happen? Yeah, it came 3 because there is no 0 now, right? You do this. There is no 0. So it doesn't need anything to represent 0. Why will we waste one column to represent 0?
So that's why when 3002 was there, one was removed.
One was removed, not
that's what I was saying. It should be 4.
Yeah. So you don't need the data. Why will you have one column with all zeros? Not required, right?
Yeah. I'm not getting it. So 3 is represented by these 0, 1, 0, 1, right? That is a column.
3 is represented by 0, 0, 1.
0, 0, 1, that's a row.
Right.
So
one is
row is being represented in the array format as 1. So actually one column got removed actually. And one column already had like all the zeros. That was the first. Okay. So this is second, third, fourth. 0, 1, 2, 3.
This is the vector representation.
Let me if it is.
Yeah, 1, 2, 3, 4 just be one.
Basically the index of every row.
Yeah.
0, 1, 2, 3.
See what active features mean? You tell you which column is what. So when you see this column, you see that first column means 1 value, second column is 2.
Okay.
Right. So what is the first value? 2. So 2 means second column will be marking 1.
Can you 0, 1, 2, 3?
I give that, but that was creating a lot of columns, and I think that is why people are confused. But see this here, you have 2 here. 2 means second column value will be 1. 1 means first column value will be 1.
Okay.
2 means second column value again. And if I 1 means first column. So if I add one more type of values, that is 0, then how many columns you need to represent it? 3 columns. Right. Okay, 3 columns. First column represents 0, second column represents 1, third column represents 2. Okay, so when it is 2, it will make third column as 1, rest of the stuff will be 0.
When it is 2, will make third column as 1.
Right.
Why?
You
put 0, 1, 2, 3, it will be better to understand. Yeah, this is the complete thing.
Each column means the number corresponding to it.
0 means first column.
Yeah.
First row will be 1.
Right.
And 1 means first row, no, second rows. It will be like 0, 0, 1, 1, 2, 2, 3, 6. You can consider like that. Then you will get this matrix.
Right. See, this is first column. First column means 0. So this value is represented by setting this in the first column and so on. I think it's clear now, right? This is so what are you doing? Basically, a number you are converting into vector representation. This is known as one hot vector because one of them will be hot. Hot means
actually basically it was vector we are converting into matrix, right?
You're converting 0 to like this, 3 to like this. This format is known as 4 vectors in this case, right? We are
so one vector we are converting to 4 vectors.
One data you are converting into vector of size 4.
That is one data. That is not vector.
That is not vector. That is a data. I mean, you can call it vector. You can call anything as vector. But here this is a data, and this is the one hot vector. One hot vector means one of them will be hot, one of them will be up. Okay, others will be 0. So if I mention 5 here, what will happen?
5.
So one more will come.
One more column will come, right? Yeah, and it will be set to 5, and here we will see the mapping. You're carrying laptop, just write this piece of code, I guess.
You will be sending this one.
This is uploaded.
It's already uploaded.
Clear?
So one hot encoder means one hot vector same thing.
One hot encoder is a technique, one hot vector is a resultant. This technique is known as one-hot encoder. Okay, this one-hot encode, using this one-hot encoder, this is very useful. I'll use it, especially in deep learning courses. We use it a lot because in deep learning, what happens? Every algorithm expects output to be in this format. So there you'll use it a lot. Here in here also we'll use it a lot.
Active features giving the value.
Active features gives you the information which column is what. Fine.
So in this fifth one means the fifth column is coming. And if I had 7,
then one more column, 7 column will come.
Instead of 3, you add 7.
Then it will not change because the number of columns required does not change.
Actually, where all the rows are 0, that it is eliminated.
All the columns is 0. The entire
not coming.
Yeah.
It should come till 7. 7 plus 7 it should come.
But we don't know it need it, right?
But
that is it will compress it. Okay, everybody got it? Now try to understand the next line. See this, what happened. So one hot adder, we have passing n values 2, 3, 4.
So that means the 2, 3, 4.
2 means, so here what you're telling here, you will create one hot encoder for 3 values. 3 values. We have 3 columns here, 1 column, 2 column, 3 column. And each first column will need 2 entries to represent, third column need. So this is the data we are doing fit transform. Okay, actually let me just keep the output like this. Take 2 minutes. Think how can we get this? Okay, just see, we are trying to represent this 3 data and we have these 3 values. Understood, right? This can be.
It is 4 now.
Huh? Where it is 4?
4 array.
And then just some examples here. 2 plus 3 is 7. Sorry, 5. 5 plus 4 is 7.
5 plus 4 9.
Oh, sorry, 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. First hint. Okay, now tell me how am I getting this? Right? Got it? I'll get some reward for the bonus. Alright, it's interesting actually. It's like mathematics. How you're doing is to see it for 1 minute.
Can we get a water bottle?
Yeah, that was the price.
There's a pattern listed, right? The second row is second data, the fourth data, and the sixth data are ones. So the third row, the first, fifth, and seventh, and the fourth row again.
Thing like that. It's better to divide this entire array into 2, 3, and 4.
Okay.
Then consider the data that we have.
0, 3.
0, 0, 3. So 0. So it has 2.
But exactly, actually, the values are 4, but here that is given 2, 3, 4. The 3 values are there, but vectors are 4, right?
You see, it's 2, 3, and 4. So consider the entire array divided into 2,
Then
3,
then
the rest. Therefore,
What I am
then
getting is
then
that
still another is left, right?
each vector will be in each row. First row will correspond to first array, second row will second array.
first
Third
data set
row.
will consider the part of the
Third
first
row will be third array and fourth row will be fourth array. And what I am getting is that
Yes, go on.
first row will correspond to first array, and now 2 columns for the
See,
first data.
one thing everybody understands, this is represented in this side. I think everybody understands that, right?
And now 2 columns for the first data. So 0 will be represented as 1 0. So it will be repeated 2 times 1 0 1 0. And after that, second 0 will be represented as
in 3. It has
in
3.
3.
Yes.
Awesome. Good. Yeah, that's it. So that's why 2, 2, 3, 3, 4, 4. This 3 is represented by this 4 data, right? So this is that's what.
Okay, so that's why 4 values are there, 4 rows are there, 4 columns are 4 rows are there.
Right? So good activity. You know why we can't use more than 7-8% of our brain? Any reason?
Because we are dependent on the APIs. Seriously, we are not doing coding. We are using formulas.
No. Okay, come on. You thought this out.
No, but seriously, if someone is asking me, for example, in Java, do the sorting, I am giving them the API. Use this API.
What she's trying to say is that they do used to, doing
memorize all the algorithms and formulas.
No. I'll tell you the purpose. Because they don't want you to waste time in sorting. They want you to use sort function and do something more complex. The entire evolution of software industry is not because, I understand when you talk from the company's aspect, a lot of things is made easy, right? Because of the libraries and all that. But the ultimate motive is for the industry or for the thing is not that you'll be hung around in APIs. The purpose is you use this API to solve something more complex. Okay, I mean, the point we start appreciating this, we will think about the next level. That is why, why are you learning this machine learning? Why is this AI coming into the picture? Right? Because they don't want you to waste time in doing repetitive tasks, right? They want you to do something new. That's the motive. Okay. Let's come further. Okay, dig vectorizer. Now we are getting into strings. Okay. Okay, this is a pretty interesting case. You can see here we have, a dictionary here, list of dictionary. Okay, you have you are importing this dig vectorizer from this case, and you are creating a transformer here. Remember, you are creating a transformer object. Okay, now from that you have a list of dictionary here. Understand, each row is treated as a dictionary. Key of the dictionary becomes column name. Value of the dictionary, value of that particular thing becomes the value corresponding to it. So you can see here, this can be understood as we have seen earlier how to convert a dictionary into data frame. This is a row. This is city column, Dubai, London, San Francisco, one column, and you have temperature, another column, 33, 12,
Just understand that. Now what do you do when you do fit transform? A beautiful thing here is the number is anyway number like this, but the text Dubai, London, San Francisco is converted into this, isn't it? Wow. Can you understand now why this is? What is this? This means first column is Dubai, the second column is London, third column is San Francisco. The mapping is done, right? So now you understood how, suppose you have a column which is like male-female representation. Okay, you have a column which is male-female representation. Now, what you can do is you of course cannot use this string in data processing, right? You have to convert this into numbers, right? What will you do? You will create one column for male, one column for female, and whenever it is male, that male column will be 1 and the female column will be 0, and vice versa.
One second, like for Dubai, like first column is 1. So London second column is 2, 1, and this is 1. But for temperature, why it is like
You don't want to delete. That is a numerical data, right? It will be like that only.
So only the text value it converts.
Right. Because that's the point of contention here. Numerical data is anyway ready for doing computation here. Text value is the one which needs little more attention.
How is this different from one?
Yeah, exactly. How it is different than 1
This is not much different from 1-hot. This is just dealing with string. 1-hot vector, 1-hot encoder do not work with strings. Okay. This guy works with strings. That's all. Otherwise, output is same. Numbers. Given a
So
number.
it just randomly convert 1 to 0 like that.
Ratings. They will depend on sequence, right? They depend on sequence, right?
This the output data that will be generated definitely deals with, you change the order, it will change. But once you fit it, it will generate the same sequence of stuff. Understood, right? Remember, here you have fit transform. That means you are creating a mapping here.
So the basic thing that is this now Dubai, London, San Francisco is there. So 1, 2, 3 it has taken. If I add another row with London, so will it take as value 3rd or will it still consider as value 2?
Come in.
So Dubai, London, San Francisco, it has taken 1, 2, and 3. Like that, it has given that one this vector output. Now, suppose if I add another row with the London and temperature something.
That will be another row.
If we add same row again, again some other temperature. Now, then how it will represent?
Any answers?
So should this suggest the temperature will change?
That's it. Right.
CD is defined.
I'm importing it.
Okay, like that.
Understood, right? One question here. Okay, of course, you saw me using, I'll just delete this line, okay? Okay, now you see this, you have this data frame here, and you are doing this fit transform here.
If you add another row with different value, then how it will come? Like how you are showing before.
Yeah, so now just the important point here. Now you understood, right? What will fit do? It will create the mapping. It will not do the data. It will not generate the data. See this? Right, because it didn't generate it in data. So what will it do? It will just create the mapping. Okay, so if I have to do the transformation, I have to do like this: db dot fit. The transform, right? Understand these things. These are like heart of the entire. So it is doing this, and see, it is showing a sparse matrix, right? Because a few contents are there. So whenever you get this sparse matrix and you want to dump the entire content, you can do this to array. It is showing you the content. Great.
Okay, remember this thing here. During fitting, during training, you have passed Dubai, London, and San Francisco. It knows only about it. It does not know more than that. Now, if I do a transformation for a data which is more than this, what will happen? I'll show what I'm trying to do. So your fitting is happening. Okay. So
we have only passed the data.
Yeah, it has created the logic. It is not doing any transformation. You're not getting in the output. Okay. You have new measurements. Okay, then you use guys, tell me it will work or not.
You have done a fit, okay, for measurement, but you are doing a transfer for new measurement. There is no fitting for new measurements. But if you create the
see, if I comment this line, it will work. Okay, no issues with that. If I uncomment this line, my question is, will it work or not? If not, why? If you understood this, you understood the entire fitting infrastructure. Will it work or not?
It will create a new data set with respect to the old. With respect to Dubai.
showing 0, 0, 0.
Not yet fit that data. Okay. That's it. Nothing has not been done yet.
What does it mean?
Other than that, everything is.
It is taking some default value, right? Understood, right? See, you have to understand there is no magic that happens. You have passed it in the training data set when doing the fit phase, so it knows now. It knows now if it is Dubai, this is what you have to do. It is San Francisco, this is what it has to do. But if you are giving some new data, how does it know? It doesn't know it. Okay, so it will give you some default. In this case, it's 0. Clear, everybody? Okay, understood? So remember, when you are training the models and you are doing this sort of transformation, you have to do you have to make sure when you are fitting it, you take into consideration the future test data as well, so that the fitting model is ready when the new data comes.
I didn't get actually.
I know. So you are actually creating a logic which can do the transformation from data from one format to another format, right?
This fitting will be, and mapping will be restricted to only those data for which mapping will be done.
Right.
For new data, it will leave the default.
See, just listen to this line, very carefully. Okay, you did this. You have some data. Okay, you are doing transformation. You are training after doing the transformation, you are basically training the estimator. Okay, now you get some new data. You have to do some prediction.
Right.
Okay, for that new data also, you have to pass the new data from the transformation. Then it has to go to the predictor.
Right.
Understood, right?
Right.
So when you do the transformation, you have to do the transformation on the same transformer which was used in the training.
But it will not be any better, right?
That's the key point here. So if you're expecting some new words, like Delhi, Mumbai, you have taken all, you have created all the mapping for all the cities, then it will be fine. If you're getting in a new, it is not ready. Right. So you have to again do a fit for new city. Right. Then you have to do the transformation. Understood, right? Keep this in mind.
So same transformer we cannot use.
Same transformer we should use.
But then it will be
right? Yeah, I mean, we have to make sure. I mean, when I say you have to make sure that whatever you are using in training, don't worry, I will see this in details. But the essence is whatever you are using in training, you have to use that in validation or testing as
well. But for the new fields, what we'll be using in the validation, for those it will be like this, right?
So see, that's the thing here. So if you know that these are the new fields that you will see, right? So you have to make sure you are using them in training the model as well. In transformer.
So say for these examples, Dubai temperature. So suppose that in my train data is like Dubai and test data is temperature. Okay. Initially I train the model using Dubai given temperature, San Francisco given temperature. Now I have to predict what will be the temperature for Bangalore?
No. Of course. I mean, don't compare it with predicting. But say in future, you know that you'll get Bangalore also and Mumbai also. So what do you do here in the training phase itself, fitting phase itself, right? You'll pass this Mumbai and Bangalore here itself. So because you have to create the mapping. Forget about prediction. You're not predicting Mumbai or Bangalore's temperature. You have to create a mapping.
Mapping should have
key value pair. So because you will need it in later stages, right?
But value
it will not consider it, and we want it to consider. For that, what will you do? We'll actually, but that's what it's done here. When you're doing this mapping, right, the fitting part, you basically combine training and test data together, then do the fitting part.
It is like a map. They have given the key.
Yeah, because
but we do the training and test data, not on the future data, right?
Really, see, I mean, training. If you are getting some future data and for which new information is coming in, which your model do not have any idea, you have to do some, more changes in the code. There, you have to go there, do some more training with this future data. Then you have to handle it, right? I mean, it is definitely not 10 lines of code, right? See this. No, don't. No, I mean, of course, these are meant to. Only when you are confused, will be able to understand.
These step is before applying the algorithm, right?
Right? See, don't connect as of now with that. Just listen first. See, first you suppose have Dubai and San Francisco in the training part.
Correct.
Okay, so that's what I'm saying. You when you are doing the transformation should know about both training and test.
Correct.
Right. And so in the beginning itself, when you're doing this, you will train it with Mumbai, Bangalore and all that.
But you don't have the target data for this, right? How you can...
No need target data. This is transformation anyway. You are talking about feature transformation. Right? I don't know temperature. That is also when I can mark it 0. I just want to take care of my Delhi Mumbai strings. Okay. See, the thing is, you should have a mapping.
Of city temperature, these both are like features, not the target. Feature data.
Feature data. Actually, the reason why you're getting little confused is we're taking little forward. Okay, don't worry about that. Just know about it that when you are doing the transformation. Okay, and for the prediction, you need the same transformer. That is the same transformer you need. Okay, because the same transformer is which using the. Because transformer creates a number like this, which is used in training, right? You need these numbers to mean the same thing when you are doing the transformation or when you are doing the prediction. Okay, so just keep this in mind. We'll use it later on. So we'll see, how the sequence. So this will happen. What we are trying to do is we are trying to independently build the logic. And when you solve a problem, we'll be connecting all of these things. Just take that with pinch of salt if there is some logic.
So how do you update the model instead of training the whole model?
There are techniques. There is like something known as model persistence. Okay, there are what will it do? You will actually create a model, train a model, save that model, mail it to you. You can mail it. You don't need in the same system. I just tell you use this is how my data set is. You can pass your data set to the model. It will do it, and you can retrain a model. Okay, so all these things are possible, not everything. Yeah, during the end of this stuff, when I will be showing how to persist a model, how to save a model, how to ship a product, deploy a product, right? I'll be showing those things.
So is text considered, this is used only in case of dictionaries?
No, more I'm showing. Say for example, you have a text document like this. Okay, we'll use these utilities, so don't worry. So we have a text document like this. You can see this is like a review comment, like random text. Earlier it was like one word only, right? So our one-hot vector or the previous conflict vectorizer was working well, but not with this case anymore, right? Not with this case anymore. This is the first document. This is first line. This is the second line. This is the third line. This is the fourth line.
What is this? This is list.
This is list of strings. What you have to do now is you have to convert. See, you have created a data frame out of this, right? Data frame out of this. What you will do now is you have to convert this into a data frame of numbers, something like this. Won't that be great? So from a text, you are converting into a vector like this. So that is what you are doing here. From a text, you are converting that to a vector.
How it's converted?
How it is converting, we'll discuss now. Okay, this is the input, this is the output. Clear? Okay, so we are using something known as count vectorizer. First point. Second point, okay, second point is you are creating a transformer which is count vectorizer object, whatever you have seen so far. And what it is doing, you're doing a fit transform. Fit transform means it will do the training part as well as transforming part, and it is showing up here. Now we need to understand what is. So if you do see transformer dot vocabulary, it will tell you what is each column like. First column is and. So whichever text has and, it will mark it as 1, or if it has more than one and, it will increment the counter. That is why it is known as count vectorizer. Understood? Yes. So see this first column is I just want to show the data. First line has this is the first document awesome food, some junk information. So you can see the next column is like in the previous case also we had each column means one word, right? So next column is awesome. So this first line has awesome, that is why it is marking 1.
Four lines means 4 rows.
4 rows, right?
So these first, if you try to match, what is this value? This, like this is the first word. This.
See,
this is
And is the first one.
And is the first word. See this and means column number 0. The order does not matter here.
And okay, and is there because in the third line and is the first.
No. In first, so and is not there in the first line, right? So that is 0. And is there in the third line. I mean this guy. Okay. So that is why you will see and is equal to 1. Understood, right?
Basically, this count vectorizer counts
number of occurrence of that particular word. Okay, see here in this case, this has
the first question is why that many columns are there?
Because total number of words are many, right? See, each word means 1 column.
Unique.
So how these many words are at least there? 12 words. So that is why 12 columns. Whichever text has word corresponding to it, it will have 1 value assigned there.
This value get assigned randomly or
no? The order is typically alphabetical order. The order of the words, because here you can see and awesome document first, it is alphabetically it is using. And what is the value that comes here? It typically is how many times that word is repeated in the text. You can see the word 2 is coming here, right? In the second row. So what is this 2? Second. So second line should have 2 times second. See, 2 times second it has, right? That is why this guy is 2. Understood?
So first and is equal to 0.
And is 0th column. Awesome is first column. Document is second column. First is third column, and so on.
Okay. And every word is a column. How did it
see whatever.
The column numbers. See, you can vary after every word the number that's a column number.
Column number, yeah.
And how number of times those words will be replicated in a particular line.
And this is the row.
That will be
the value corresponding to it. Right.
So row is the line. So 2 means 2 times it got repeated in the second line.
Yeah. 2 times means that particular word, which is that particular word, second. So fourth last column, right? Second is the word.
What if there are some other words like a name? So other will be considered.
You can control.
I mean, does it see vary this function consist of all the words that in normal dictionary, or
it can be an invalid word as well. Slang and all.
But if it like use text, then
of course. I mean that is why trick comes into which. I mean, of course, if you say this way, how many words are there in English dictionary? As a data scientist, one should know that 1.6 lakhs. Okay, how many slangs are there in it? And in real world, people use that. Right? Not infinite, but it's huge. So, and of course, there are a lot of things like not good is a word, one word, right? People use not good is a negative word, whereas good is a positive word, right? So a lot of things are there.
And special characters also that also it considers.
There are ways. I mean, it will like it remove the cap case, right? It made all small case. So those things are there. I'm coming to that. I'm coming to few things. Now, you can control now that is the trick part. You cannot do a computation on 3 lakh columns, right? If you try to do that, you'll never get a result. You get a overfitting case. You take too much time to compute. Not possible. So what you need to do is you need to get important words, relevant words, right? We'll see how to do that. And also, like in case of suppose you are doing bus trip. I mean, there's one case we did for Red Bus. They have this customer writing reviews about bus. Then there is a case of Zomato, right? Zomato people write about food, and in reviews the important words are adjectives, right? Important words are adjective. An adjective for food and adjective for bus travel would be different. Understood, right? So the same code will not work for all of them. Text is a huge area. Okay. So now you can tell, stop word means you are not interested in this word, the and is. No, these are not inbuilt. So in the same eliminated. Yeah, true. Right. If you mention stop word is equal to the and is, your final the final vector will not have the and is. Understood, right? And at the same time, if you mention stop words English, okay, it will mean there are a lot of these words like first one, a lot of words which based on default English dictionary does not consider important. Okay, that is what it is taking into consideration. Okay, then the next word is you want to make use of mission and food, only mission and food. Like for example, in Red Bus they don't want to use a lot of other words, but these 3-4 words I want to do my keyword. Yeah. Absolutely, you're getting the finer control right here. Right, so you are mentioning it. So you have one way of mentioning stop words, one way of mentioning vocabulary.
So after doing this, what we do, like after forming this, we input this to some other.
Absolutely.
Okay. So this is how in the NL works.
Yes.
So
and a lot of more things are there.
So say, as you said, for Red Bus or Zomato. So if I got some vocabulary or adjectives and we transform this one, then if we feed this data into an algorithm. So what can be the output like? Can be like this logic, like distance wise, like what they wanted to do.
See, business wise, they wanted to predict, what type of people, what type of sentiment is it? People can write tweets, right? But what is the sentiment towards it? Is pro government or against government, right? Which area is more pro BJP, pro Congress, pro some other party? Right? So, this is sentiment analysis is one area. Then predicting rating from reviews. Yesterday only I was doing it somewhere.
But that one, for doing that one sentiment
see this.
For doing this sentiment analysis, we need this machine learning because we can very well count the number of occurrence of those lines.
You will
suppose adjectives are there, 2 adjectives are there in a text, big text. So I can very well count the number of occurrence of those.
So if I suppose I'm writing about food. The restaurant is okay, food is good, but I'm not satisfied with the overall experience. People write this comment. What is this? What is this text? Is it a positive comment or a negative comment? And how can you conclude it based on the number of adjectives? Understood, right? Text is really complex because humans are complex.
So
we have some reviews. I really liked the studying and everything, but I think it could have been more better. So this is real because right. So humans cannot. I mean, if you try to do it yourself as well, how many comments will read it? I mean, I'm talking about like this is Amazon food reviews. I was doing this. This is towards another class in the evening, which is in the back end phase. So there you can see there the data set was some 80 lakhs or something. So there we have review. See what you have reviews like this. These are your reviews. I bought the several validity and all that. Okay, and this is the rating. So what you have to do from the review, you have to predict the rating, right? So remember for text data. So what we did here in moving, see this count vectorizer I'm using, TF-IDF transformer. One more technique that we'll study. You're basically converting your data into numbers. Pipeline will learn this, right? So we got around first algorithm we got around 70% accuracy, right? And I was trying with other algorithm. I think we'll stop there.
So what is the outcome? To
outcome is you will pass it text there, and it will tell you whether what type of rating is it. Is it a
like classification?
Classification case.
So like put on the positive or negative.
Positive. No, it is 5, 4, 3, 2, 1.
Oh, like based on the
right.
we'll feed the reviews and we will give the positive as the 0, 1, 2, 3, 5. That is the main issue, like where we can go to machine learning and where we cannot. Like not cannot, where we should go and where we should not.
So as of now, park this thought. Okay. As of now, just learn it academically. Okay, when we do projects, I think a lot of these things will open up. So don't worry about it. Like nothing is done in a day, but a lot of things definitely gets done in a period of time. See, that's what we learned it here, and later on, it will connect. Like Steve Jobs mentioned, right? Importance of connect. I think everybody has heard that, right? Okay, this was one technique, count vectorizer. The next thing is TF idea vectorizer. Okay, it might be a little over today, but last I think.
So where
few more things to do. I think
vectors like this is only for dicting, or is for transform?
No, vectors you will use for vectors. Any data is a vector. Now onward, right? I mean, when you talk to somebody in machine learning, or you talk, so you have few vectors. You don't see them. I don't see you as a human anymore. not literally. Everything is a vector, right? I mean, for you we are a vector for mobile data companies, because they. Right?
Matrix also will say like collection of vectors.
Vectors is like vectors combined together, right? So say the next.
It can be used in any algorithm.
Algorithms works only on vectors. Okay. Next is TF idea vectorizer. Again, a very useful stuff. See, the previous case that we saw here is it is telling you how many times that word is coming. It's not really telling you how important that word is. The it can come 10 times, but is the an important word? Right? Why is the not an important word? And how do you realize it?
And it is not important.
Now parts of speech, those things are there, but can be not an important word. How do you realize? So that the thing is, I'll explain this with Wikipedia. Okay. Suppose you have Wikipedia page documented. Suppose you have Wikipedia page downloaded. You have say 1,000 persons profile details. Okay, right from presidents of US, presidents of India, politicians, sports persons, some 1 lakh entries are there. You take up one document. You try to find what you have to do. You have to find important words in this document with respect to entire corpus. Collection of document is known as corpus.
Like the resumes are not.
Yeah, I can imagine that. Okay. So how do you have to do? You have to find important words in this document with respect to the entire corpus. What happens is the entire corpus, words like the, is will be there in many documents, and apparently those are the words that gets used most often. But if there is article and then you see Obama word is there. The Obama word is there more compared to entire corpus. In entire corpus, only 1 or 2 times the word may be there. But here, this document consists of a lot of times the Obama. Right? That means Obama is an important word. Politician is an important one in this document. Right? So that's what the important thing is. From every document, you are not finding the word alone. You are finding important words in a decreasing order. Okay.
Important word in the means of number of occurrences.
No, not only that. Like in this case. Suppose you have a document where 2 times Obama is there versus 7 times the is there. Which is more important?
So who defines priority?
Who defines priority?
Nobody defines it. That is machine learning. It will find it by itself.
How it finds it?
I'll tell you that. Give me 1 minute. I'll tell you that. First appreciate this.
The priority of the word.
So the one thing, as you guys mentioned, that who defines the logic, right? And that is the ulterior motive of machine learning, right? We don't have to define the logic.
Somebody else has to. Okay, the algorithm will do it. So what it does, it tries to find. We are not telling it Obama is important, the is important, is important, not telling. How the algorithm does is, the algorithm, suppose I am the algorithm. Okay, what will I do is, I'll see one document, I'll see, acha, Obama is there, the is there, and I'll see, okay, Obama is there in this document, has 100 words, Obama is there 20 times. In the entire corpus, we have this many, and these are many documents which has the word, which only one more document has Obama word. What does it mean? For this document, Obama is an important word, isn't it? It doesn't have to have the knowledge. The word Obama is important. For it, there is some word which is appearing more often. This is not TF means term frequency and inverse document frequency. If a word is appearing more often in a particular document compared to the entire corpus, you say this word is important. Understood?
And
For that document.
And the term will appear most.
In the entire corpus, collection of all the documents.
For
Right.
For the particular documents, that word is most. More. That's why it's specific. So
Right. So
it finds a uniqueness.
So that's why it is term frequency. How much frequent? What is the term frequency of that word in that document versus inverse document frequency? Apart from that document, in how many other documents is that word appearing?
But if I input only one document.
And that word is important. We'll see this. Give me 1 minute. I'll show it as an example, and we'll realize it will find for us the important words without we telling it. Okay. Let's see. This is also inside feature text extraction text. This is the library. I'm not. I think I have not spoken. So this is the library from which you're importing it. You're creating a TF idea vectorizer stopwords English. Okay, that means it will not take into consideration some basic words. Okay, you are doing a DF text.
Stop words in English. Stop words.
Like you'll not take into consideration some words. Just like, okay, so like when you give stopwords English, is, the, and those few words, it will not take into consideration, right? Which is designed by English alphabet itself.
These things are inbuilt in the library
itself, right? So now if I do, see, if I'm doing a transform, okay, no, if you're doing a transform and I'm doing this, right? And you remember you have this DF text.
First one, right?
DF dot. So first line is there. Then you realize, okay, and you need which column is what word. So you do this. These 3 columns are important. Pay little attention. Okay, so first column is awesome. Okay, just see this. Awesome is appearing only in this document, isn't it? Only this is one document. This understand. Each line is one document.
Oh, okay.
Just understand. I mean, document can the entire text can be there. And the entire collection of this line is known as corpus. Okay, what will you see? This awesome word is appearing in the first document, and is it appearing in any other document? No. That is why you will see it is a good importance word.
So it's a weightage.
Weightage. It is between 0 and 1, and you can see it is quite decently important word. See the second word, for example, document. Document is appearing 2 times, right?
That third line, why it is 95 and first line why it is?
No. Actually, the way this is the first. This is the first row. This is the last element.
Oh, okay.
Okay. What is the last element? Last element is your second. So you'll realize that second, and this is line number 2, right? Line number 2. This line has 2 times second. That means the importance of the word is pretty high.
That's why it is
9.95. Understood, right? And see a word like, for example, 0.3. What is that word? Second word, right? Second word is document. So you see the second line here. You see you have the word document. It is lesser important than say a document in this line. It is finding out based on the relative importance. Okay. Say for example, I'll just do one thing. I'll write food is there only in one column, right? I'll write food in all the columns.
So document like first it is 41%. And second line it is 30%.
Yeah, because importance of the word document in the first line is 41%.
importance of the word document in the second document, right, is 30%.
Why less? So,
Yeah, because see, it is calculating this based on the other important words and a lot of other things are there. Okay, but the important factor here is, okay, I mean, it takes into consideration what are the other important words in this document as well, right? That is also one factor playing here. Here you can see, you have this 95%. That means this word is very important. It is overshadowing the importance of this word, right? So if you do this, if there is some word which is appearing in all of them, if I write food in all of them, you'll see the weightage of food coming low. Understood this? So this is very useful, right? If somebody is writing review text, and I have used this in my Amazon food reviews case. If you have some food reviews, you would want to find important information here. Like if you might have heard about document summary. What does it do? It actually finds all the words, all the important stuff in a document compared to the other documents, right? That is your document summary.
is this used in the NLP?
This is there in NLP as well, same like. Okay, TF, IDF, count vectorizer, all these things are obtained from NLP in scikit. This is part of your natural language processing.
NLP will be covered in this.
NLP is no, it's in deep learning. A part of it is covered. In AI, a part of it is covered. Okay, understood, right? So far.
So tell me another thing. This scheme, whatever you are showing, these are libraries, right?
Libraries.
So this is Python libraries, scikit libraries. So if I go to TensorFlow, it will be different.
You can use it.
Like same, it will be like this only, or
no, it will be different from this, or little different from this. Kira's library. Kira's library. So they have, but they also will import from an NLP only. Okay, natural language processing is a separate library. Whoever wants, they cooperate from there. Nobody implements all of it.
So it is like that matplotlib and panda. Right? So matplotlib, panda, can use matplotlib.
Everything is connected. Got a hang of this? Okay. The next thing is hashing vectorizer.
So if you remove second instead of 2 times, make it 1 time. Will that
it will reduce. It will reduce. Okay, hashing vectorization. Many times, you cannot really control the number of words, right? But you cannot keep your, number of columns infinite. Okay, so what you do in that case is, okay, so what you do in that case is, okay, here what you're telling here, you're telling here number of features is equal to 5, right? Number of features is equal to 5. That means no matter how many words you're getting as an input, you will try to bucketize into 5 columns only. Understood, right? Like 2-3 words will go to 1 column, other words will go to 1 column. This is known as bucketization. Okay, this is also known as hashing technique. From a word, you are finding a relevant number, and you are finding which number should this map to a particular column. Right? This is bucketization. So this is useful when you have too many words. Okay, you do this bucketization so that similar words get into 1 column, sort of stuff. Fine.
Can you see like what are columns?
No, you cannot see which. These are the columns. You can see these are the 5 columns. But
yeah, but what are the text got bucketed in this?
Oh, acha. Let's try that. What was the get feature names? Should show me if it is there. Number of features it is telling.
So if we get a data set, so first I think we should remove that image from like those common words. Then also if we see that number of words are coming more, then we can apply like this.
Right. Okay, so you can apply this. Like we'll use these things. Okay, hashing vectorizer. You have a lot of words. You try to put them in same bucket. Once you get these numbers, do machine learning on it. Right? Do some apply some classification techniques on it, and you get that stuff. Fine.
So putting in same bucket does what?
It reduces the number of columns you need to process the data.
We have to do it for every set of data?
No, if the data is too huge, then you can do that. Like you can see, I mean, we can combine the previous stuff. Like in the example earlier, like here, what I did is I combined a count vectorizer and TF IDF transformer, right? And it gave me some good, decent results, I would say. So showing more things. Now I'll talk about a little bit about images. Now that we have understood numbers, text, right? How to do image processing.
So here in that negative number, how it is coming? Hashing method.
Hashing method is the number. You give some level of scaling and all that.
So let's see how image is actually processed. Okay, so let me see if the image is. Yes, there are two things. Feature extraction, one is import image. I think I was not using this. And the SKey image is another library. I use pretty much this. I use this in deep learning also. So the thing is, if you have anybody loves dogs? Okay, then I'll show you a very interesting data set. The other folks are doing it actually. We have 10,000 dogs images. You have to identify which breed is it. You have different dogs images. Similarly, we'll have sweets images as well. Okay. So yeah, and you have the information, the data type. I mean, what type of breed is it and all. You can do the mapping. We'll do that. But as of now, what you're doing, your skimage.io im read, it will load the data. And if you see here, oh, the data is gone. Stuck.
Similar like SK image, we have anything for audio files as well, right?
Audio also it is here. Okay.
Is also why it is there in the
Processing scikit-learn is there in machine learning for beginners. Okay, so I'm showing it. So what will it do is, it will load the image, and the image will be in the form of NumPy. And how the image will be represented? Suppose the image is 100 cross 200 size. It will be 100, 200, 3. Okay, so image will be 100 cross 200, 3. 100 cross 200, each pixel is represented by each value, and each value is represented by RGB, 3 values. That is why each image is nothing but a 3-dimensional data structure. Understood, right? And value of each pixel will be between 0 to 255. Okay. No, it's jammed. I think I need to restart this. Or I can throw in the GitHub. See here PNG, so it is 4, but if it is JPG, it is 3. 4 means one more parameter, I think, height or that, whatever it is. It's, okay. NumPy, all NumPy array. Then imputation is known as filling the missing values. We have learned in pandas also how to handle the missing values. Here also we have some imputation.
So if we can't handle missing in the beginning,
you can do it here, yeah.
What is that?
So what you're doing, you're creating an imputer object. You are this is missing values will be represented as NaN. And wherever it is missing, what is the strategy of filling it up is called calculating mean.
Mean of?
Mean of the data, mean of the column.
How do you know when there are missing values?
Huh?
How do you know there are missing values?
So if you see the data, I mean, then we have to do info, data frame.info to show the missing data there.
So are we also supposed to consider the mean or?
Suppose you
consider the mean as a strategy or
depending on the data. Mean is a good way to fill it up. Okay, you might fill it up with zeros as well. You might fill it up with maximum number of repeating elements. Right? One of the whatever strategy you use. But the essential thing is, see, this is the data, right? You can see here, this is an NaN here. So what it is doing in place of when you do a transform here, NaN is replaced by this guy 4. Understood, right?
4 is the mean of
1 and 7.
Okay. The remaining 2.
Clear, right? Imputation.
So all missing values.
Imputation is one technique. Then you have polynomial features. Okay, we have used this earlier, right? What is it doing? Given a particular value, it is creating a degree of fundamental. And last thing, you can create your own transformer as well. Okay, so what is it? This is pretty important for interviews as well. How to create your own transformer, right? So what are you doing? You are creating a function transformer. This is the API function transformer. Function transformer, and you are passing the logic over here. Given a data, it will add 2 to it. So if you are this is the data and you do transformer dot transform x, it will add 2 to all the data. Understood, right? Right. So that's it. This is how.
So this transformer input, what it is taking, that is each
value, it will undergo this operation.
Each value from the
data. Each value will undergo this operation. This is your pre-processing library. This is most of the stuff that will come across. In documentation, you will see quite a major chunk of it.
So this thing has to be done before applying the algorithm.
Right. Okay. Any questions?
The previous one, I think you went too fast. Custom transform.
Which one? This one? Sorry, polynomial is the same that we did in linear regression. So what we did here, 2, 3, 4 we had, right? 2 it created 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. 3 raised to power 0, 3 raised to power 1, 3 raised to power 2, 3 raised to power 3. Okay, and when you give 2, 3, 2 raised to power 0 plus 2 raised to power 1 plus 3 raised to power 1 plus 2 raised to power square, xy, y square, and all those. Same as what we have seen.
If you do 0, 1, 2, can you do 0, 1, 2 fit transform?
Yeah, then 0, 1, 2 in this case. 0, if you do all the values will be 0 here, right? 1, 0, 0, 0. That's it. Clear? These are utilities that you'll be using in, before you pass the data. You're not clear about polynomial features.
What is it? 2, 3, and 4?
2, 3, 2 data, right?
It's the same like
Same. X, Y, X square, Y, X, Y square. Okay.
No. You give 2. First element is 2, and second element is 3, and third element 4. So
2 is one data.
okay.
3. I mean, this is 3 datas with 1 column each, right?
So why do you use transform in custom transform?
Why do you use custom transformer? Customer many times we use.
Over there, why don't we use the transformation of custom?
Now, this is the basic custom transformer which will take the logic and given data it will just transform it. Okay, so that's what it is.
What will you cover next?
Next will be our classification.
Logistics.
Yeah, logistic classification you use.
But the feature selection and all.
I'll use classification. Then we'll come back and use feature selection. Then you'll use. So this thing has to go, or the connection will be missing. Okay, because if you do this, then feature selection, then the gap that will be in your mind is when you apply what. Right? So we need to go back to algorithms, little more algorithms. Then you'll do feature selection. Then you'll do pipelines. Then little more algorithms.
Also, tomorrow, if it is possible, can you show an example where first some of these things will be done?
Tomorrow
then,
we'll do. Text processing will do tomorrow. I'll show you tomorrow what we'll do. You'll see working with text data as an example here. Working with text data. Pipeline. So we'll discuss how text data will work, how pipeline works, how logistic regression works.
Pipeline is for the library package.
The package. Okay, guys, let's catch up tomorrow. Go through the stuff today. Try writing little code around it. Okay.
And pipeline will be later.
Let's see. I think we can do it depending on how much understanding is there. Because I think pipeline is not possible tomorrow because we'll do classification. Okay.
Yeah. So this classification also like feature selection, like that is common across all the algorithms. Feature selection
is common across all.
Like this.
Right. I mean, we'll identify what features to use. So, yeah. Who was saying something?
This is Tribhuvan. I was saying about last week's video. I was not able to attend the class.
Last week video. Last week video is actually, I mean, not the previous class session, but the previous batches. I'll tell you, in the YouTube search for Zclabs data science, there you will see one video on scikit-learn and just search for this one. Scikit-learn first video. There are two videos actually. I would have spoken about Zclabs. So Zclabs data science, if you see, there are so just follow this. Machine learning using scikit-learn, not 2, 1 and 2. Follow 1 and 2. Where is 1?
So last week's class was on linear regression.
Yeah, linear regression.
Okay, the polynomial part that has been completed.
Yes, polynomial part is completed. I have the recording. What will I do is then I'll upload. I'll share. I have to do that. Okay. Okay. So you can see the notebook was there. So I spoke about polynomial degree and how to find which one is best. We had this discussion. I'll try to upload it today. Okay.
Yes. Okay.
Okay. I'll end the session. Thank you. MATLAB is without Python if you're doing machine learning and all that. You pass the data, it will do the visualization, get the logic. No, MATLAB. Alternative. Like non-programmable. I mean, you do not non-programmable. You don't have to write a lot of code. As well. Also libraries is more of a tool-based. MATLAB.
So it's like for this Python like this. MATLAB is completely different.
Different, yeah.
It's really the calculations.
One thing I have a question. There are so many other features within, let's say, the functionalities that exist. Each of the steps that we're learning. So, is there a way to prioritize the functionalities that we're learning? I'm just taking an example. Let's say one hard encoder and big vectorizer. In vectorizer, there's a clear indication that it is for text. Whereas one hard encoder is for the numbers. So the same way we learned EFIDA vectorizer. So is there any way in terms of we can say that okay, this will be utilized specifically in these scenarios so that we can
TF-IDF is good for text processing. We'll do a text processing case. We'll use TF-IDF vectorizer. We'll see that
So let's say from big vectorizer to TF-IDF vectorizer, I have to take a call which one to use. First, I need to be aware of in terms of what are the advantages and disadvantages of both the techniques, right? Then I'll be able to take a call.
Yeah, I mean, this is the same stuff. You might have to try with both of them. Right. So, I mean, accept this. I mean, the sooner the better. I mean, the thing is, I understand this is because, we have, I mean, if you are coming from traditional programming, this is not the way we do it. Right. That is why there is a paradigm shift over there. Here you have to understand that, it is not called hit and try. It is called iterative process here. That's just connect it to chemistry lab. I mean, go back to class 12. How is to do it to create something? Is to do this experiment, and based on what works out. This is what scientists do, right? That is why it is called data scientists, right? Because you have to experiment out a lot.
Right. Other than one hot encoder, is there any other encoders on say the techniques which are there for numbers? Because we touched only on one hot encoder today, right? Is there any other technique? Or is that the only one?
Of course, there are others, but this is what you use more often, like very often compared to others.
So how do we cover those techniques? So in terms of which you have not covered.
Right. So the thing is, what I am discussing is mostly, you'll be using 80% plus time, 80 to 85% plus time. Of course, if you see the information regarding any of this thing, it's huge, right? I understand, the information blast that we face all these days, right? For anything, it's huge.
That's why I asked in terms of there are three types of variations that you're telling. PDFI, hashing vectorizer.
See, whatever type I'm telling, I'll be using them. Yeah. Okay, I don't say that whatever I'm doing that is everything. I can't say that. Okay, but it is definitely something. It will always help you in getting to certain stage, right? Okay, so that you have a dependent problem, you know how to solve it. You can attack a problem. You can take up a Kaggle problem. You should be able to solve it with decent equations. Then comes the fine tuning part of it. Okay, take it step by step. There is definitely no magic formula to reach there, but at least in the initial stages, focus more on solving the problem from start to end. Okay, you might not get 95%. You might get 85, 87%. That is the accuracy you are getting, but you know that process. We repeat this thing every time. You will do some same problem with different things. Will tend to improve. Okay, so
I understand what you're saying, but my question was in text. You have told us three techniques.
This is what
you told us one technique, and you're saying that 80%.
No, we use that scalar techniques also, right? Okay, standard scalar, min max, absolute scalar. All those techniques are there. But one hot encoder was one way of doing it. So a lot of these techniques are there. You see documentation mostly, I've covered almost all of them. But having said that, I cannot say this is all. Okay, because there are a lot of things that comes to
There's a lot of syntax ways I'm seeing that still memorized.
So don't worry. Just suppose we have discussed this today, but you go. I mean, if you get time today, just try writing this code, play around with it. Tomorrow we'll do something more. Just be connected throughout. Just carry on doing this. By the end of the course, you'll feel that everything is connected. Even if you don't know, like whatever technology, like for example, you are working in Java. Okay, you'll definitely not know all the things in Java. But you definitely, by working sometime, you know how to approach a problem. If you know, that is just stage. That is the output of the course. I mean, by the end of it, even if you don't know something, you will not give that expression.
But this transformation thing, whatever you said, so whether these are specific to Python or if we go to API.
No. This is across domain.
Across all the
R also you will see something very similar.
But the things are syntax may be different.
Syntax may be different. And in fact, syntax also a lot of them will be same.
But the standardization process is more
the process that you're learning, right? It is not. I mean, I'm less of Python, more of a process.
That's what.
Right? It is same throughout.
Library
is the same. Okay, I'll end the meeting. Carry on.